Welcome to this lesson on naming alkanes, more specifically branched chains. The first step is to identify the longest continuous chain. One common terminology you will come across when it comes to naming organic compounds is alkanes. But what are they? So in this lesson, our focus is to look at the various bonds present in organic compounds. Now we can compare these intramolecular forces to the force between members of a nuclear family. So you have the father, the mother, and their children. This kind of force between them or bond between them is really strong, and it is not easy to break. So this kind of force between the mother, the father, and their children can be compared to what? Intramolecular forces. This is the force that holds the individual members of the family together to form that nuclear family. I think that's clear, right? That makes sense?
Yeah, it does.
Okay, so that's intramolecular. But look at this. In the world in which we live, you don't have just a nuclear family. Especially in some parts of Africa. We really focus on extended family as well. Some people do that a lot. There are some fields out there that also rely on organic chemistry. What are those fields?
So, biochemistry, pharmacology, agriculture, and even cosmetics.
Wow. Cosmetics. When I hear cosmetics, I think about you guys, you ladies out there.
Yeah. Life without our makeup, our cosmetics for real.
That would be a nice life, you know.
That would be awful.
You're perfect. Yeah. How like paint your faces with all this things?
We love to paint. That's also art.
What? Makeup is art.
Painting
Your face is art. Yeah. Okay, I think this is the first time I've heard this. So now, each of these carbon atoms has how many electrons in the outermost shell?
So they each have 4 electrons in the outermost shell.
So they each have 4 electrons in the outermost shell, which means none of them is stable. So they have to form covalent bond to attain stability. So this is what happens. The 2 carbon atoms move to overlap. So as they move to overlap that way, they share that pair of electrons. So that is what is shown by the line between the 2 carbon atoms. This is a single bond. Head-on overlap to share electrons. Now, after they share that pair of electrons, each of them still has 3 unpaired electrons. Do you see it now?
Yeah.
Good. Each of them has 3 unpaired electrons. So what that means is they need to bond with 3 separate atoms each. And for this case, we are going to use hydrogens. Now let's move to the step number 2. The step number 2 is to number the carbon atoms in the main chain from the end closest to the branch. So number the carbon atoms in the main chain from the end closest to the branch. So there are 2 possibilities of numbering this carbon atom. We can either number from left to right or from right to left. Those are the possibilities. So let's first number from left to right. So for left to right, we have 1, 2, 3, 4, 5 indicated in red. What are from right to left? We have 1, 2, 3, 4, 5 indicated in blue. Okay, so you are welcome to our very first lesson on organic chemistry. You are welcome to our last video on the series of naming of alkanes or alkane nomenclature, but more specifically for this one, I'll be looking at haloalkanes. This brings us the end of naming of what? Alkanes. We started off with straight chains, branch chains, and then we've ended with haloalkanes. Now our next lesson is isomerism. Isomerism. It reminds me of isosceles triangles. Isomerism, does it have anything in common with can understand isosceles triangles help us understand isomerism? What is the meaning of isomerism? That will be the topic we'll be discussing in our next lesson. So now we know how to name alkanes. Is it possible the same molecular formula can give you different structural formula. That will be the focus of our next lesson. See you